Okay. Okay, so let's begin. Good morning to all of you. We were here, I told you on the any other method. We are discussing our method which we have developed, and I think its copy is already available on your what you call Moodle. Moodle. This copy is by numerical integration of boundary value problem, and I am one of the authors. So, it is there. Okay. So, please read that paper, and so I am saying this is not only, and as we noted yesterday, that this method is semi analytical, because we are assuming solution in one direction and analytical solution which satisfies boundary condition at the two ends. Then once I substitute that solution into the governing partial differential equation, which is 2 dimension, then I will get one dimensional equation. One dimensional means ordinary differential equation in the other direction. Okay. And then there is some manipulation which needs to be done in order to use this method, and that is, so we are considering now 2 dimensional problem just for simplicity, not 3 dimensional. So, we have got all these things I have already told you: equilibrium equations, strain displacement relation, stress strain relations, all these are there, and that defines your problem fully. Now, the problem is solution. So, numerical integration helps you so there are 8 unknowns, 8 equations in 2 dimension. There are 8 unknowns and 8 equations, but it can be shown that these 8 equations, the gist of the 8 equations can be written in terms of just 4, in terms of only 4 variables. So, out of 8, see, first of all, u and v is a definitely displacement is a primary variable, you want it. Then you have got 3 stresses and 3 strains. Now, stress and strain, if you know stress or strain, either of them, if you know one, other can be found out from constitutive relation, is it not? Stress or strain, it is related by a matrix S or C. So, then it is easier. So, that means out of these 6 only 3 are, so 3 plus 2 5. Now, I am saying even 1 can be reduced, that 5 it can be reduced to only 4, and this I will show you. So, I can write down all my elasticity equations in terms of only 4. I mean, elasticity means this 2 dimension, this is 2D, this is in the case of 2D. 3D, of course, there will be more, there will be 6. 3D, it will turn out to be 6. So, in 2D only 4 unknowns can be expressed only in terms of 4 dependent variables. Thus, there are only 4 dependent variables in terms of which the entire 2D elasticity equations can be cast. Now, this is not written in any book. So, please take it from me. This can be done, and we will show you how it can be done. Now, this is the short form of numerical integration method. In NIM, we reduce the 2D elasticity problem to 1D by assuming an analytical solution satisfying the boundary condition in other direction. It should be other direction, that is So, this is okay. So far, I think I have already. So, we had taken a problem of beam, and this was the beam. This is a beam in 2D. Beam actually is a 2 dimensional problem, plane stress problem, beam. It has length and it has got depth. Now, I am using, only thing is, instead of x and y, I am using z. Z means we are all used to transverse displacement W. we always say W means the displacement along the if load is applied, then W is the displacement. We do not say V. So, instead of x and y, I will write it in terms of x and z. Is it okay? 2 dimension, and that is what I. So, with the objective of reducing the dimension of the problem to 1D by assuming an analytical solution, we here in this case we obtain a set of first order ordinary differential equation. This is important. A set of first order ordinary differential equations ODE in only 4 dependent variables. I told you out of 8 only 4 are important, only 4 variables we will write down, and how it can be done. Now, how do you choose this? In fact, you can choose any 4 out of 8. There are many other methods where they use any some other, but here in our method we try to choose the 4 dependent variables which naturally occur, because if this is my x, I have just drawn, this is a depth, I have taken a depth of h, and I am fixing my coordinates in the center of the beam. So, this is my origin and this is z upwards. Load also is applied upwards positive. So, load also is there. Which is, so this, now if I take any z equal to constant, see this I have written here, z equal to constant. If I take any z equal to constant plane, or it will be line here, z equal to constant means this one, this I have shown it here. So, this is my z equal to constant, z equal to constant plane. From here, what do you mean with z constant? Means this you cut it. What are the quantities which occur naturally at z equal to constant? At any z equal to constant, we can realize that means this is my plane, this is z equal to a positive. So, on this one, on this surface, of course, at this point, supposing I am interested, I will like to know what is the displacement along u, what is the displacement along vertical direction, that is z. So, u and w, these are the 2 quantities. So, this again I have shown it here. This is my z equal to constant, this is my, this is z equal to a constant, any edge, any plane in this direction, in z direction. So, on this you have u, you have w, and corresponding to u, see here there will be shear stress on every face. See, this is my z equal to z direction. So, on this one there will be a shear stress. So, shear stress means corresponding to u, the shear stress will be tau z x, and corresponding to w, w is like this, there will be also on this plane, on this line, in 2 dimension it is a line, otherwise it is a small plane, width having b, small width b. So, then in this direction you have the normal stress which is sigma z. So, my basic quantities are a vector y which is u w tau z x tau sigma z. So, I will just show you how to write down all these 8 equations by simple elimination. We can write down only in terms of these, no other variable, everything will be only in terms of these variables. Then I will, and I want to get a set of ordinary differential equation. So, ordinary because I am influenced by my ODE integrator. Yesterday I gave you some idea about how to integrate, how to develop a stepping scheme. So, idea is that I should be able to find out at z, starting from z equal to here minus h by 2, go in this direction at z equal to h and cover the entire depth, and I will use my some integration numerical integration procedure in finding in moving in z direction. So, my equations must be first order equations. First order equations. So, there are 4 variables. So, I am interested now, my equations will be so I intend to, because so I think I should write it before this. So, I am interested in getting my first order equation of this type. So, I want to get, there are 4 variables u, w, so I would like to get on the left hand side like this each equation. Then right hand side also I would like to get some a square matrix of 4 by 4 multiplied by u w see, I am not having any other variable other than these 4, everything is only in these 4. And here inside this, of course, there will be 4 elements, 4 by 4, 16 elements. There can be, this can be either anything derivative of x or function of x inside, not function of z. See, z is occurring only here, derivative. Here right hand side I will get, I want to get only this. Why I want to get this? See, function of s, there is no problem, I can always substitute the value of function of x when I am going through, when I am going to in z direction. Similarly, derivative again I have no problem, because I have already assumed a function in x direction. So, I can write down the derivative of that function. So, this is okay, I mean it can be. So, like this matrix, and then there can be also some loading term, because there is a load. So, there will be non-homogeneous means it is independent of these variables, loading term, LOAD, load term. So, this is the form in which I will get my equation. So, how to get this? So, first equation I will try to get. So, this thing you already know, you have got 3 sets of equation that can be reduced to only 2 sets of equation. One is this stress in terms of displacement. From Hooke's law you can just write down, substitute. See, this is my Hooke's law, these are my 2 dimensional Hooke's law, and then I have substituted for strain displacement. From strains I just substitute for displacement. So, I get rid of strains, 3 strains are now not in the picture. So, now I am dealing with how many variables? 2 displacement and 3 stresses. See, if you take this displacement, see this equation, see I have, because you are so much used to x and y. So, everywhere I have made a mistake. So, this is my, I am saying this is my x and this is z, this is u, this is w. So, then this is my sigma x, substitute for this epsilon x would du by dx, epsilon z will be dw by dz. Is it okay? You are following? It is just strain displacement relation, only thing I have changed, instead of y z, nothing else. So, and why I have done this? This I have explained, because in a beam or any, you always think in terms of a plane, vertical plane. This is x direction, this is my transverse W, because W, since I want to bring in W, means it has to be z direction. So, y is going inside the paper, x, y, z, z is upwards. So, y is going in the width direction. So, this is my displacement one equation, this is my one equation, this is another equation, and this is my third equation. Now, I have got rid of here, got rid of strain terms. This is sigma z. Yes, sigma z. Here also this is x z. So, got rid of 3 strains. So, now we have how many? U v plus 3 stresses. So, now we have I think 3 stresses to 5. 5 means U v, and stresses are sigma x, sigma z, and tau x z or z x. 5 variables. Now, I want to reduce this to 4. I told you that it is possible to write down everything in terms of 4. So, I have got one more equation, that is equilibrium, because this plus this is my total set of equations, plus of course boundary conditions, plus always never forget boundary conditions, because then only the problem is completely defined. So, this makes problem completely defined, and mathematically it is called a BVP, boundary value problem. So, this is, so I make use of 1, 2, 3 and then these two 4 and 5 for, see, number everything tallies. So, now we have got 5 equations and 5 dependent variables. I will get rid of 1. So, please get rid of 1. So, one by one I want to express everything in terms of this. This is my model. I want to write down like this, because I basically I would like to integrate. So, what I will do? So, this is now, see, one thing I see from 4, equation number 4, I can see clearly that tau zx is a required quantity, is my preferred quantity here, and then del upon del z also is there. Then this one also is a function of x. So, it can go on the right hand side, and this also can go on the right hand. So, one equation I directly get. So, from here, so this is where I 5, 6. So, from equilibrium equation, I this one number 4 equilibrium equation I am just writing here, and therefore, this is. So, this form, the form of the above first order equation is ideal for NIM. This is ideal, why? For the reason, because I have assumed some solution for, I will be assuming some solution in x direction. So, then this derivative can be found out. This is the body force which will be given to us, and this, after I have assumed the solution in x direction, this will transform into ODE. So, everything finally you cannot integrate a partial differential equation, you have to transform this into ODE. Since I will be assuming some form in in x direction, so this will be converting into ODE with respect to. So, this is the required form. So, 1 I directly get 1 in one variable. Now, let us see the other ones, and for that I need to see always this, I need to have always this in front of me. Now, next one, which is the best, if you take this, but then this is required. So, this will go on the right hand side. Of course, just now we have found out this. So, that can be substituted. So, that is one alternative, because this is no, but then this is with respect to x we have found out with respect to z. So, that is not that will not help us. Now, let us see any other. Yes, I think from here this one number 3, I am not going in any order, because we want our equation in this form. One equation I have already got, this equation I have already got. So, now let me take this. So, number 2. So, this is my 1. Now, number 2, take equation number 3 from equation 3, and equation 3 is tau x z is equal to E by 2 1 plus nu du by dz plus dw by dx. So, from here equation number 3 I will try to get my required form. Yes, please. I will try to bring this du by dz on the left hand side. So, du by dz equal to 2 1 plus nu by E. I have multiplied this tau x z minus dw by dx. Are you able to see this? Yes, you are able to see. So, then I have just multiplied this. This is okay? No mistake, na? Is this in the required form? Required form like this. This is my required form. No. Tau xz is my required quantity. I want to express everything only in terms of my 4 variables. So, tau xz is okay, and w also is okay, and then w, this derivative of x. So, derivative of x is possible on the right hand side. Right hand side, any derivative of x with respect to the 4 variables can be put. Okay. So, this form is okay. So, this is number now my second. This is my second required equation. So, this I got. Now, this is okay. From this one we got from 2. See, from 2 here also, from 2 here, because there is already dw by dz, dw by dz, and this is with respect to x, and this is my required quantity. See, sigma z also is my required quantity. So, it is okay. So, 2 also is another candidate for immediate. So, now you take 2 from equation 2. Now, from equation equation 2, and what is equation 2? Equation 2 is sigma z is equal to E by 1 minus nu square dw by dz nu du by dx. Therefore, I get here dw by dz is equal to 1 minus nu square by E into sigma z minus nu du by dx. Is it okay? Everything is okay. So, u also is a required quantity, there is a derivative with respect to x, sigma z also is my required quantity, and this is with respect to. So, this is also okay. So, this is number 3. Now, comes one more is there. Now, how many equations we have already made use of? We have taken these 2, we have made use of 3, we have no, I think 3 ना कि 5 नहीं भाई zx किया है, सिग्मा z किया है पहला, कहाँ सिग्मा z कहाँ है भाई, पहला वाला तो ये है. What is sigma z? First one is what? This is equation. Which equation is this? Acha, it is sigma z. Okay, it is sigma z. So sigma z, and okay, fifth one also is done, sigma z. So fifth one is okay, and then we have also taken 4 also we have used. No, 4 is not used. So this is equation number, I will just write it here from equation number 5, so that it is clear. Okay, so what we have not used so far is number 4 and number 1. Now you think of it. Yes. So first what we need is, we need a derivative of sigma, we need a derivative of tau zx. So we start from here. We start from this one, number 4. So from equation 4, equation 4 we can write down that del tau zx by del z is equal to minus del sigma x, it is to be eliminated, by del x minus bx. This is okay now, there is no mistake from equation 4, yes, z x z bx, this is okay. So 4 I have used. Now please make use of number 1, sigma x. Sigma x is given by, so minus del upon del x, sigma x is given by here, sigma x is given by E by 1 minus nu square du by dx plus nu dw by dz. So now from this list of 5 we have taken 4 and we have also taken 1 substituted, you have substituted. So, it is all the 5 have been used. Now, let us see, this is okay, form is okay. Here also there will be second derivative of u will come, that is okay, that is all right. So, this is my required, there is no problem. Problem is only here second derivative of w with respect to, but then this can be eliminated because we already have this number 3 which we have derived. So, we can substitute this and then I will get it my. So, this can be substituted. So, this can be substituted from here. So, you will get everything in the required form. So, that will be equal to minus, see E can be, if E and nu are variable along the x axis, beam is not uniform, that also can be taken here, but then you do not have, then you have to put it like this only. If they are constant, then only it can come out. If these are not constant, then it will remain as it is and it will be variable. So, but let us assume here for simplicity that these are constant, 1 minus nu square del square u dx square minus nu E nu del upon del x and then del w by is 1 minus nu square by E please see this, if there is any mistake we can just, is there any mistake? So, now everything is proper, right hand side whatever, this is okay, this also, if again here these are variable, then this has to stay as it is, otherwise this can come out. So, okay, so let us say everything is constant. This and this will get cancelled, this E also will get cancelled here. So, I will be left only with nu. So, minus nu del sigma z by del x, then minus minus plus, this minus minus plus E nu square second derivative of x you can see this is my, so minus minus plus, this is E nu square 1 minus nu square and this del upon del x second derivative of u with respect to minus px. So, this is okay. So, this is fine, everything is as per our requirement, u is there which is our required quantity, z is there and then derivative is only with respect to x. here, oh, this and this can be combined, this and this can be combined. So, now we have one more task to do. Now, how to combine 1 minus nu square common. So, what will be left, please? So, E 1 minus nu square, the 1 minus nu square will go, see, minus, if I say minus E 1 minus nu square. So, then this will be this minus nu square, and then yes minus. So, this is okay. So, this and this will get cancelled. So, I will be left with minus nu So, this is now my 3 and this is my. So, fourth one was little involved, otherwise. So, I have got 4 equations. So, one is this, this is, then third is this, second is this, and first will be the first one somewhere here. First one is only one line. Now, 1, 2, 3, 4. 1, 2, 3, 4. So, they can be written in matrix form. So, these 4 equations can be written in matrix form. 24, 0, 9. So, I get this. So, 4 equations can be in matrix notation or in matrix form. I will have a particular order u w tau zx and sigma z. This order I will maintain. We will see what are these. So, first for u, where is number u? where is u? U is here, this one. So, du by dz. So, I want to write du by dz is w. So, where is w is second, u is coefficient of u is 0. So, first term is 0, here w by del x. So, there is a derivative, this is a derivative matrix, del upon del x. Second term is this one, I am writing this. So, dw second, dw by dx with a negative sign. So, negative will come here. Third one is tau zx, tau zx is there, tau xz or xzx is okay. So, it is 2 1 plus nu divided by E. Third one. Fourth one sigma z, there is no sigma z, so 0. So, 4 terms. Second one is this, second one z. So, u minus nu del by del x. So, minus nu del upon del x. It is a derivative matrix. Then w, no, gabad ho gaya, nahi, this is okay. W is 0, tau zx is 0, and so second one is 0, third one also is 0, fourth one is 1 minus nu square by E. This equation number 3 is written in matrix notation, nothing else. dw by dz, second row. So, it is sigma z, yes, last one, minus nu del upon del x by u. Okay. 0 0 कर दिया ना बीच में. अच्छा, body force also is there. Where is body force? अच्छा, okay. So far both the had no body force. So, yes, here body force 0, very good. Okay, so there is nothing in this one. Then next one, tau zx. Tau zx is this. Tau zx is this. The u is there, sigma z is there, only 2 u. So, minus e second derivative of x is there. Is it okay? U, and then w 0, second 0, then tau also 0, this also 0, and then yes, this one is there, minus nu del upon del x minus bx. So, here I will write here. So, if there is a bx, that will come here. By the way, when we multiplied by something e or something, bx is not multiplied now. Check, I mean, I should not have made any mistake. Somewhere I have, but not in this, I think it is okay. All right, so this is okay, bx. Then fourth one, sigma z. Where is sigma z? Third, sigma z is here. This is sigma z. The sigma z is a function of u and w. Sigma u and w. So, E nu by 1 minus nu square, E nu, where is sigma z by sigma? This is not sigma z. First equation, sorry. This is not sigma z is this. Yes, it is only tau xz. So, this is 0, this is 0, and w also is 0, tau, so this is equal to minus del upon del x. again this is 0 and minus. So, this is a form. So, I have written this in a form which can be again, because since I am writing y is equal to u w tau x z sigma z transpose. So, then this can be written as del upon del z equal to, this is some matrix A square, it will always be square matrix A, which is a function of x only. All this will become function of x only, A multiplied by y plus this we call it some loading matrix P. So, in you can write in any order. You can write it any order, but then whatever order is here same must be maintained here. I write somehow I like this order because this is my u, the corresponding to u there is a shear, then this is my w, corresponding to w there is a normal stress. So, I maintain that order. First I write displacement, then this and this they have a relationship. So, I do not that is, and I have maintained this throughout right from beginning, because I have been practicing this method for the last 30 years, 35 years. So, it is okay. Or these days you do not write this, you have a bold face in computer, which was not there in olden days. In typewriter we used to do like this. Now, you write y del upon del z equal to some bold face A into y bold face plus P. So, this is a vector equation, that is all, nothing else. All these are. So, okay. Now, this is defined, this problem now is defined in z equal to going from minus h by 2 to plus h by 2. Differential equation is always defined in the domain. This is a partial differential equation, of course, so far it is partial, time, okay, partial. So, this is defined in this. I have not used equal to. Why equal to is not used? What is equal to? What does equal to mean? See, I have written z minus h by 2 less than z less than plus h by 2. So, if this is your thickness z, so I have not included the two ends. Why? What is a simple answer? One, Rajeshwar, you should be able to answer. Boundary, yes, yes, that is the boundary. Here you have to provide boundary condition. These are the boundary points. Here also boundary condition. Then its problem becomes, so your differential equation is defined here with boundary conditions at z equal to. So, this will be at z equal to minus h by 2 and this will be z equal to plus h by 2. That is all. So, the domain, this is the domain, I am stopping, this is my domain. Domain of the problem does not contain boundary, that you should remember. Okay. So, this is number 9, all right. We stop here. So, this is a special form in which we write our equation for this procedure.